Welcome to Lexopedia, where knowledge meets your curiosity. Prepare to embark on a cosmic adventure as we delve into the wonders of our solar system. Today, we turn our attention to Jupiter, a celestial giant that has captivated astronomers for centuries. Jupiter reigns supreme as the largest planet in our solar system, a gas giant of truly awe-inspiring proportions. Its massive size and gravitational pull have shaped the solar system we know today, influencing the orbits of comets and asteroids. Jupiter's influence extends far beyond its own system of rings and moons. Just how big is Jupiter? Imagine this: if Earth were the size of a nickel, Jupiter would be as large as a basketball. In fact, Jupiter's mass is greater than twice the combined mass of all the other planets in our solar system. To put it simply, over 1,300 Earths could fit inside this colossal giant. One of Jupiter's most iconic features is the Great Red Spot, a colossal storm that has been raging for centuries. This swirling vortex is so large that it could easily engulf the entire Earth. Scientists believe the Great Red Spot is a high-pressure region in Jupiter's atmosphere, with winds reaching speeds of up to 400 miles per hour. Section 5, a celestial entourage, Jupiter's moons. Jupiter, the giant of our solar system, is not just remarkable for its size and swirling storms, but also for its incredible collection of moons. These moons, each with their own unique characteristics, form a fascinating entourage that orbits the gas giant. Jupiter boasts a remarkable system of over 80 moons, each with its own unique story to tell. From tiny, irregularly shaped rocks to massive planet-like bodies, the diversity among these moons is astounding. They range in size, composition, and geological activity, making Jupiter's moon system one of the most intriguing subjects of study in our solar system. Among the most famous are the four Galilean moons: Io, Europa, Ganymede, and Callisto. Discovered by Galileo Galilei in 1610, these moons were the first objects found to be orbiting another planet, challenging the geocentric model of the universe and revolutionizing our understanding of the cosmos. Io is a volcanic world, spewing molten lava from its fiery depths. It is the most geologically active body in the solar system, with hundreds of volcanoes, some of which erupt with plumes reaching hundreds of kilometers into space. The intense volcanic activity is driven by the immense gravitational forces exerted by Jupiter and the other Galilean moons, creating a dynamic and ever-changing landscape. Europa, with its icy surface, is believed to harbor a vast subsurface ocean that could potentially support life. Beneath its frozen crust, scientists speculate that there is more than twice the amount of water found on Earth. The possibility of an ocean beneath Europa's surface has made it a prime target for future missions aimed at searching for signs of life beyond our planet. The smooth, icy plains and chaotic, fractured regions on Europa's surface hint at the dynamic processes occurring beneath, making it one of the most intriguing objects in the solar system. Section 6, faint and ethereal, the rings of Jupiter. While not as prominent as Saturn's majestic rings, Jupiter does possess a faint ring system. These rings are composed of dust particles, likely originating from collisions between Jupiter's moons and passing asteroids. Although difficult to observe from Earth, Jupiter's rings serve as a reminder of the dynamic forces at play in our solar system. Section 7. Jupiter's powerful magnetosphere. Jupiter possesses the strongest magnetic field of any planet in our solar system. A magnetic field so powerful that it stretches millions of miles into space, forming a protective bubble around the planet known as the magnetosphere. This magnetic field traps charged particles from the sun, creating intense radiation belts that can be hazardous to spacecraft. Section 8. Curious Tales from the Giant. Here are some curious facts about Jupiter that will leave you marveling at this celestial wonder. Jupiter, the largest planet in our solar system, is a gas giant that has fascinated astronomers and scientists for centuries. Its immense size and unique characteristics make it a subject of endless curiosity and study. A day on Jupiter is surprisingly short, lasting only about 10 hours. This rapid rotation is the fastest of all the planets in our solar system. Imagine the sun rising and setting in just a few hours. This quick spin contributes to the planet's oblate shape, meaning it is noticeably flattened at the poles and bulging at the equator. However, a year on Jupiter is equivalent to 12 Earth years. This means that while days are short, The journey around the Sun is long and leisurely. Jupiter's vast distance from the Sun, about 484 million miles, accounts for this extended orbital period. This distance also means that sunlight is much weaker on Jupiter than on Earth. Jupiter is composed primarily of hydrogen and helium, much like a star. In fact, it is often referred to as a failed star because it has the same basic elements but did not acquire enough mass to ignite nuclear fusion. This composition gives Jupiter its characteristic bands and zones, which are visible even through small telescopes. If Jupiter were about 80 times more massive, it would have ignited into a star. This hypothetical scenario highlights the fine line between planets and stars. The additional mass would have increased the pressure and temperature at its core, initiating the nuclear reactions that power stars. This fascinating fact underscores the dynamic and diverse nature of celestial bodies in our universe. One of the most iconic features of Jupiter is the Great Red Spot, a massive storm that has been raging for at least 400 years. This colossal storm is so large that it could engulf Earth. The Great Red Spot is a high-pressure region with winds reaching speeds of up to 400 miles per hour. Its reddish hue is still a mystery, with theories suggesting it could be due to chemical compounds or the effects of sunlight on the planet's atmosphere. Jupiter also boasts a fascinating system of moons, with 79 known satellites orbiting the planet. The four largest moons, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610. Each of these moons is unique, with Io being the most volcanically active body in the solar system, Europa potentially harboring a subsurface ocean, Ganymede being the largest moon in the solar system, and Callisto being heavily cratered and ancient. Another intriguing aspect of Jupiter is its powerful magnetic field, which is the strongest of any planet in our solar system. This magnetic field is 20,000 times stronger than Earth's and creates a vast magnetosphere that extends millions of miles into space. This magnetosphere traps charged particles and creates intense radiation belts, posing challenges for spacecraft and potential future missions to the planet. Jupiter's magnetic field also gives rise to spectacular auroras at its poles, similar to the northern and southern lights on Earth, but much more intense. These auroras are caused by the interaction of the magnetic field with particles from the solar wind and the planet's moons. Observing these auroras provides valuable insights into the complex magnetic environment of Jupiter. While not as prominent as Saturn's, Jupiter has a faint ring system composed mainly of dust particles from its moons. These rings were discovered by the Voyager spacecraft in 1979 and are divided into three main components: the halo ring, the main ring, and the gossamer rings. The study of these rings helps scientists understand the processes that shape planetary ring systems. Over the years, several missions have been sent to explore Jupiter, including the Pioneer and Voyager missions, the Galileo orbiter, and the Juno spacecraft, which is currently studying the planet. These missions have provided invaluable data about Jupiter's atmosphere, magnetic field, moons, and overall structure, deepening our understanding of this giant planet and its place in the solar system. Future missions, such as the European Space Agency's JUICE, Jupiter Icy Moons Explorer, and NASA's Europa Clipper, aim to further explore Jupiter and its intriguing moons, particularly Europa, which may harbor conditions suitable for life. These missions will continue to unravel the mysteries of Jupiter and expand our knowledge of the solar system. Jupiter's immense size, unique characteristics, and fascinating features make it a cornerstone of our solar system. Its study not only helps us understand the planet itself, but also provides insights into the formation and evolution of the solar system as a whole. As we continue to explore and learn more about Jupiter, we are reminded of the vastness and wonder of the universe we inhabit. Section 9. Unraveling the Mysteries Missions to Jupiter. Throughout history, numerous spacecraft have embarked on missions to study Jupiter. These missions have significantly expanded our understanding of the largest planet in our solar system, revealing its complex atmosphere, numerous moons, and powerful magnetic field. Each mission has built upon the discoveries of its predecessors, painting a more detailed picture of this gas giant. Pioneer 10 and 11 provided the first close-up images of the gas giant. Launched in the early 1970s, these spacecraft were the first to traverse the asteroid belt and make direct observations of Jupiter. Their images and data offered humanity its first detailed glimpse of Jupiter's swirling clouds and immense size, setting the stage for future exploration. Voyager 1 and 2 revealed the intricate details of Jupiter's atmosphere and moons. Launched in 1977, these twin spacecraft conducted flybys of Jupiter in 1979, capturing stunning images and data. They discovered active volcanism on the moon Io, intricate ring structures and complex atmospheric phenomena, including the Great Red Spot, a massive storm larger than Earth. The Galileo spacecraft, which orbited Jupiter for 8 years, made groundbreaking discoveries about the planet's composition and magnetic field. Launched in 1989 and arriving at Jupiter in 1995, Galileo provided unprecedented insights into the planet's atmosphere, revealing the presence of ammonia clouds and lightning. It also studied Jupiter's moons in detail, discovering evidence of subsurface oceans on Europa and Ganymede. Galileo's data on Jupiter's magnetic field and radiation environment have been crucial for planning future missions to the Jovian system. More recently, the Juno spacecraft, launched in 2011, has been studying Jupiter's poles and deep atmosphere. Juno's unique polar orbit allows it to gather data on Jupiter's gravitational and magnetic fields, providing insights into the planet's internal structure. Its observations of the polar regions have revealed massive cyclones and auroras, offering a new perspective on Jupiter's dynamic atmosphere. Looking ahead, future missions like the Europa Clipper and the European Space Agency's JUICE mission aim to further explore Jupiter and its moons. The Europa Clipper, set to launch in the 2020s, will focus on studying Europa's ice shell and subsurface ocean, searching for conditions suitable for life. The JUICE mission, scheduled for launch in 2022, will study Jupiter's 3 largest moons, Ganymede, Callisto, and Europa, providing a comprehensive understanding of the Jovian system. Section 10. A universe of wonder awaits. Jupiter, with its immense size, swirling storms, and diverse collection of moons, serves as a constant reminder of the boundless wonders that lie beyond our pale blue dot. As we continue to explore our cosmic neighborhood, we can only imagine what other celestial marvels await our discovery. Section 11. Join the Lexopedia community. Like this video if you found it fascinating, share it with your friends, and ignite their curiosity about the wonders of space. Subscribe to Lexopedia for more captivating journeys into the realm of knowledge. Join us at Lexopedia because knowledge is power and curiosity is the key. Subscribe today.